Okay, hello everyone. Today we're going to look at permutations. Okay? And tomorrow we're going to look at combinations. Today's objective is to define and count permutations. The essential question, and you'll need this for the homework check: how do we count the number of possible arrangement subsets? All right, we kind of looked at this a little bit. All right, we're going to look further at it today. Just to review, guys, remember we talked about a factorial. We talked about it yesterday. 4 factorial, 4 with an exclamation point. It's shorthand for 4 times 3 times 2 times 1. That's what it means. All right, again, the factorial function, this exclamation point, that's the symbol. It says to multiply all the whole numbers from the chosen number all the way down to 1. So look at the example of 7 factorial. It's 7 times 6 times 5 times 4 times 3 times 2 times 1, okay? 1 factorial is 1, and 0 factorial is 1. 0 factorial is not 0, it's 1, okay? However, suppose we're running a race with 6 runners. How many arrangements are there for those runners to finish first, second, or third? Again, we looked at this yesterday a little bit. Again, 6 runners can finish first. And once we have that first place established, there's only 5 runners left that can finish second. And after those first 2 places are set, there are 4 runners that can finish third. All right, so 6 times 5 times 4. There's 120 possible ways for 6 runners in a race to finish first, second, or third. This is known as a permutation. And this is the proper notation right here with the big P. It starts with an N, which is the total number of objects, and R is how many we're arranging. So N is always bigger than R. N is the bigger number, R is the smaller number, okay? It's written like this. This is the formula. All right, N factorial over N minus R factorial. All right, so how many ways can we arrange 6 3 times? An arrangement of 3, but picking from 6. All right, it's 6 factorial divided by 6 minus 3 factorial, which is 3 factorial. So again, the 3, 2, 1 goes away on the top and the bottom. We're ended up with 6 times 5 times 4. That's how we got the 120. Again, by definition, a permutation is an arrangement of some or all the objects in a set in a specific order. All right, the number of arrangements of n items arranged r items at a time is right here. All right, this is the formula we talked about. Again, n is the big number, r is smaller, and they're both greater than 0 or equal to 0. Very important. In a permutation, order does matter. In an arrangement, order does matter. All right? An example, how many 3-digit numbers can we write using the digits 1 through 5? All right, that's a permutation. It's 5 permutate 3. We can think of it like that. 5 permutate 3. So 5 factorial on the top, and the bottom is 5 minus 3 factorial, which is just 2 factorial. All right, you end up with 5 times 4 times 3, or 60 is the answer. And you can think of it like this. When it's 5 permutate 3, we want, starting with 5, the first 3 numbers in the factorial sequence, 5, 4, 3. You pick the first 3 numbers in the sequence, starting with 5. Again, as another example, how many different ways are there to choose a president and a vice president from a list of 8 candidates? Again, that's 8 permutate 2, because it's just president and vice president. All right, so 8 factorial on top, and 8 minus 2 factorial on the bottom, which is 6 factorial. Again, the 6, 5, 4, 3, 2, 1 on the top and the bottom cancel out. So we just end up with 8 times 7, or 56. There's 56 ways to choose a president and a vice president from a list of 8 candidates. And again, start with the 8 and list the first 2 in the sequence. 8 times 7. So that's one way to think of a permutation. Again, another example, if we had 7 permutate 4, it would look like this. It would be 7 factorial over 3 factorial, which just ends up being 7 times 6 times 5 times 4, or 840. One thing I want to point out, 4 permutate 4. That's the same as 4 factorial. All right, 4 times 3 times 2 times 1. There's 24 ways to arrange 4 things 4 ways with 4 slots. All right. 4 permutate 1. All right, I'm just going to choose 1. There's 4 ways to do it. All right. I'm choosing from 4, so I'll just pick 1 each time. There's 4 ways to do it. The last one here I want you to notice is that 4 permutate 3 is equal to 24. That's the same as 4 permutate 4. And the reason for that is if you think of the 4 permutate 4, I could just take 1 out each time. There's still 24 ways to arrange it. All right, guys, that's it. You can go ahead and do the homework check if you'd like. All right, thanks.